I have a very simple question. Once you developed cryo-EM, did you expect you will win the Nobel Prize?
Okay, well, so I think it was already mentioned that I'm the 16th person to have a Nobel Prize in one lab, so it's not so special for us. But about 10 years ago now, we were just doing our work actually. So we don't pay too much attention. Although I think every year you should listen, 4th and 5th of October, when they make new announcements. But one of our PhD students in 2012 said when we were going for coffee, he said, "Do you think you will get a Nobel Prize?" And so I said, "Well, you cannot predict it because the committee, and there are areas of research which they've missed. For example, there was never a Nobel Prize for the mechanism of muscle contraction, and we don't quite know why that was, but they don't do every year. And so indeed in 2017, when the prize was announced, we were actually, several of us from the lab in Cambridge, we were at a meeting in Leicester because they had just bought one of these very expensive microscopes. It was being inaugurated. So we had probably about 50 or 60 people. It was a joint Japanese-British meeting, so there were 20 or 30 people from Japan. And I'm sitting just like you are in the audience when my phone rings. It's about 10 o'clock in the morning. And if your phone rings in a meeting like this, you should not answer it. So I pressed "Do not answer." And then it rang again. So then I thought I'd better look to see who was calling, and it said it was a phone call from Sweden. So I thought, well, I very rarely get phone calls from Sweden, so I better. So I went out, and then it turned out it was the chemistry committee about an hour before they announced it publicly. And so they said, okay, there's a Nobel Prize. So I said, well, I can just go back to the meeting and carry on. However, about 10 minutes or 15 minutes after the Nobel Prize phone call and press conference, emails start to arrive. And once they reached about 1,000 emails, I decided perhaps I would go back to Cambridge and make sure I was there to join a party. And when I was there, they were already having a party. And they don't need the Nobel Prize with it. They just need an occasion for it. So I think it is all great fun actually. And then a month or two later, you have to go to Stockholm to get this medal from the king. And so and you're allowed to have, at least the year I went, you were allowed you were allowed 12 guests. So I thought, well, our children and grandchildren, they might like to come. And one of them said, "Oh, I don't think I can get away from school. The school won't let me go." But we said, "Nonsense, this doesn't happen very often." So the school they all came to Stockholm. And then one of them made the mistake of telling her chemistry teacher that her grandfather had been given a chemistry Nobel Prize. So the chemistry teacher then gets very excited, more excited than we are. And so then I had to go to the high school of one of the grandchildren. And then when the other grandchildren heard that I had to go to the other schools as well. So yeah, so there is if you are getting a Nobel Prize, there is an obligation to do some activities that you wouldn't normally be doing. Because it is a very good foundation. They do a lot of publicity, advertising, outreach, and it does raise the profile. So actually, whoever gets the Nobel Prize every year, it helps all the countries to convince the politicians and the treasury to put more money into science. So I think, obviously Korea, you should, every October, you should take advantage of whoever gets it, doesn't matter where, to talk to all the people who perhaps are in control of the budget and try and leverage it to produce more investment in areas of science. And I think it works really well. So since then, I've done a bit more other activity than just basic research. But I was also rescued because exactly a year after our 2017 Nobel Prize in Chemistry, the same committee decided to give it to Greg Winter in the same lab. So then he had to do all of the outreach work, and I could happily go back to being a normal scientist. So that was
I mean, the Nobel Prize on cryo-EM is actually a wonderful collaboration from a very distinct discipline like yourself, Dubrochet, and Joachim Frank, who are very different people. So normally, my experience as well, like if you were in the same laboratory, collaboration or conversation with these people would have been very productive and possible. But you were in all different places and from all different disciplines, however, worked out so well to make this breakthrough. How was it possible? Like, how did you kind of communicate or discuss or work together with the other two, like Joachim Frank and Dubrochet, and work out for this cryo-EM?
Yeah, so obviously now there are thousands of people doing cryo, but let's say 40 years ago, there were not so many people. And indeed, I think Dubrochet's plunge freeze method, very few people knew about it. I think at that time, I was on one of the committees in Europe, the EMBO course committee, when I heard about the work. So we suggested there should be an EMBO course in it, and Dubrochet ran one about 1984 or 1985. And then other people, so yesterday we had Hua Chu was also visiting here after the international. Hua Chu and Nigel Unwin asked the Gordon Research Conferences to start a meeting, and that was the first one was 1985 in the sort of cryo-EM, 3D EM Gordon Conference, and there were about probably less than 100 people. So it was a very small field, so we all knew one another. And so our very first image, I didn't show it today, but our very first image of Bacteriodopsin purple membrane by cryo-EM that gave high resolution was taken at EMBL on Dubrochet's, it was a Zeiss with a Siemens lens with a man called Jean Le Paul. So, I had visited there with an EMBO fellowship, travel fellowship, several times to collect data with Dubrochet. And then Joachim Frank came for a sabbatical to Cambridge for 6 months, about 1987 or 1988. Hua Chu came for a year or so. So the community was very small. And actually, even in that graph, which had the plateau and then the inflection point, 2013, there weren't many people doing cryo-EM actually. They all said, oh, this was low-resolution blobs, blobologists we were. And so in our lab, we had about probably 10 or 15 people doing cryo-EM on 1 or 2 microscopes. But then the new methods came in, and actually usually it wasn't the group leaders, it was the PhD students who said, this is much easier than what I'm doing. And so there was a big flux of people into it, and then there wasn't enough time on the mic. So then the field really took off, and so in our lab now we have maybe 150 or 200, so a third of the lab does cryo-EM, whereas in 2012 it was probably only 5%. So it's been a big step forward. So basically we all knew one another. Many of us had published papers together, and now the field is much bigger, and everyone has now got a more specialized role in the field. So Joachim Frank, he likes to work on the intermediate stage time-resolved ribosomes, and we've turned our attention to making the cryo hardware less expensive, because there's lots and lots of problems still, and they need to be solved, and you can't solve them unless you put your sample in the microscope. And if you have to book a session 8 weeks in advance, compared to walking up to a microscope that same day, the progress of the field goes much more slowly. So I think, basically it was a small global village which has grown to a big one now. So I think that's what happens in other fields also.